Was raised here this afternoon by our two presenters, and from the reaction of some in the audience, I know this is your time now. So this is how I'll go. 1, 2, wait, keep your hand up. 3, the young man. 4, 5. That's the order we'll go in. Please.
So, I won't try to convince you of anything. Obviously, there's such fundamental differences between what I think and what you think. It would just take a long, long time. I'll just give you some of my thoughts hearing both your talks. There are 3 main places. First, an overall. Almost every objection, I'm forgetting your name, the first speaker?
Mike Gimbel.
Professor Gimbel offered. Almost everything that you've argued comes from 18th and 19th century sources. None of it comes from, those are the same arguments that Berkeley had against infinitesimals and the analyst. These are very common, and that everybody had, including, as you pointed out yourself, Newton. Nobody accepts action at a distance. That's just a fallacy. That's just not true. No scientists have ever accepted action at a distance, and they don't today. That's just not true. That's just a misunderstanding of science. And I've spent my life committed to studying these kinds of sciences. And I'm a Marxist. I completely agree with dialectical materialism. I don't see the two as opposed as you are, and I'm not going to make a big story about that. Most of your political stuff I'm fine with and I agree with. I just think you're just wrong about the physics. You're wrong about the math completely, the math especially. You're just wrong. That's shown. It's demonstrable. We have, now I'll go to the math. That's just about physics. The stuff about the ether and all of this stuff. There's just empirical evidence about this, and I know I'm not going to convince you about it, and I know you probably read it, some of it, but you need to study the physics. I've studied the physics formally for many, many years, and I teach it, and you're just wrong. You're just not understanding how the physics works. But in the math, what you said about infinity is wrong. I mean, we have George Cantor in the 1870s has a whole theory of transfinite cardinals, and there's a whole mathematics of them. There are operations that you can do on transfinite cardinals. You're right. You can't do addition-subtraction operations with integers or with natural numbers on them, but you can do other operations on them that are just as fundamental. In fact, they're more fundamental because they're related to classes and sets, which you could say, those are abstractions and what have you, and there's a lot of discussion about those things too in literature. I mean, every aspect of what you've said, there's tons of discussion about, and to simplify it by kind of going back to simple 18th century models of what atoms are and what causality is supposed to be, I think is to treat historically, culturally bound conceptions of causality that did arise in Europe in the 17th and 18th centuries as frozen in time and as absolutes in history. And those are conceptions that people had. They're not actual facts of physics. And it's just pointless to try to make them. What makes sense is to look at the empirical data and to look at how people struggle with systematizing that data. And I can't get into this now, but there's no question that into my mind, that relativity theory is a quite amazing systematization that does help us with that point that I brought up, sorry to be so rude, during your talk, about the geometry of space, but we don't have to get into it right now, but you could say as you like.
Okay,
that's my 2 cents.
Yeah,
please, yeah.
To respond.
Before I get to the geometry of space, I would disagree completely with you on George Cantor. George Cantor tried to use the infinite, but his old base of start of using it was incorrect.
And what was that?
You cannot, anytime you start to use a number in the infinite, you have to start from someplace, from 1. At that point, you cannot, and I've looked at Cantor's stuff, it's false.
Why?
Because anytime you use a number, you're already assuming a beginning.
Right.
Infinity has no beginning. When you use a number, you have to understand that it's infinite in all directions, that number. That you've just arbitrarily selected a spot. it's, this is a little bit abstract, but the fact is that though when you're dealing with the infinite, you're not dealing with George Cantor because his models are not the infinite. They're math. They are math. I don't deny that they're math, but they're not. It does not. They do not solve for the infinite. Okay. As far as the geometry of space, I'd love to see those like four-dimensional space where included angles of a triangle don't add up to 180
Look at a
degrees.
globe. Look at the surface of a sphere. In the surface of a sphere, when you have three
Okay,
lines that are-
one second.
You got to allow some dialectic
no,
here.
no,
This is
no, I
tough
understand.
stuff, and you have to allow some-
wait a minute,
One
wait a minute.
second, one
Look at
second.
the sphere.
Wait,
That's
order please, order. Listen, excuse me, wait, I'm running the show here now.
This is left forum.
Everyone has to have a
This is not
chance.
the fascist forum.
No,
This is
no,
not
it's,
forum.
I
This is
understand
not
that,
fascist
but
forum.
the fact is, there's a time constraint. There's a time constraint, and you're not the only person here. We have others waiting. Give them a chance. All right? So don't interject. We can have a chance after they're finished for you to have another question.
It's not another question. It's
Well,
just-
whatever
No,
it
you
is,
keep interrupting.
okay? You keep interrupting. It's not
arrogant.
right.
It's arrogant.
Go ahead.
Okay. There's other
Go ahead.
people here. Before I was interrupted, let me just make this: there is no triangle of that sort.
Yes,
There are no
there
bent straight
There are
lines.
triangles of that sort. That's a false thing.
Okay, let's go to somebody else.
Listen, sir,
That's it.
sir,
It's really,
you next.
I'm not a scientist. There are a lot of weird things in science, of course. But it sounds, to try to go, it was fascinating, it's crazy. It sounds to me the best thing is that it's kind of Fred Hoyle steady state thing. Okay?
no.
No, okay,
No,
fine.
not-
How do you deal with the things that I've read in my popular science of GPS doesn't function without relativity?
False,
You're just
false,
inaccurate.
false, false.
Okay, I got
Let him
I'll
finish
just
his
do my
question. Go
four and
ahead.
then please. The atom bomb. How do you deal with that without energy inside the atom?
Yeah.
Do you, I'd like just a curiosity, do you believe in galaxy formation? Or, okay, galaxy, that 13.7 billion years, has there been an evolution of the galaxies from something, whatever you believe it is? I'd be very interested to know. Do you believe in gravity? Do you believe in E equals mc squared?
Go ahead, say either one of you.
Okay, on the last one, E equals MC squared, I've got a paper on that. Do you want to know how that works?
E
It's on the website.
E equals MC squared is not relativity. In fact, it existed prior to Einstein. The galaxies form. The atom bomb is a mechanical device. It's. I don't see where you get. It has nothing to do with relativity.
By pushing the red button.
No, it wasn't required for it.
What's the matter? It's matter in motion.
Yeah.
It's matter in motion.
And that's what E equals MC squared is. The gist of it is that the matter in motion inside the atom is being transmitted to outside of the atom. To what? To the ether. Okay? Now, if you're in ether denial, then you've got to call it energy, a magical matterless motion. Okay? We're taught to believe that we have actually turned matter into energy. Okay? And that's not true. We have transformed one kind of matter in motion into another kind. That's all we ever do.
Do you believe in energy?
Remember what I said energy was. Energy is equals MC squared, and it is a matter in motion term. It's a calculation. It's not a thing.
If I throw a bullet at you, it'll bounce off. If I put it in a gun, it blows you away, right? All it is the matter in motion. It's not like the energy blows you away. It is the matter that blows you away.
I thought that C squared said, gee, there's an awful lot of energy there that's not in the matter if you don't bring in the energy inside the nucleus, the strong force.
You're doing that.
Okay.
Okay.
Next.
Young man? Yes?
So I actually wanted to discuss three of the specific claims about physics that were made, I think, by Michael. Specifically, the relativity of time, the claim that matter only exists in three-dimensional space, and that the Big Bang creation was creation from nothing. So I don't know how much of the history of 20th century physics you've read about, but as it turns out, special relativity doesn't actually necessitate that time is relative. So Henri Poincaré and Hendrik Lorentz had a formulation of special relativity called the Lorentz ether model, which described all electrodynamical interactions in terms of a mechanical ether medium that one couldn't observe through, say, a Michelson-Morley type experiment. So it was consistent with Michelson-Morley. Subsequently, there are general relativistic extensions of the Lorentz ether model, which are consistent with all known predictions of classical Einsteinian general relativity. Einstein recognized this himself. In fact, later on in his life, he commented that his specific operationalist formulation of relativity couldn't be the end of the story because it doesn't give a causal account of relativistic phenomena like length contraction, time dilation. And so he actually, at the end of the day, sided with Poincaré and Lorentz. Now, also to add to that, we know from quantum mechanics, specifically the violation of Bell inequalities in quantum mechanics, that if you try and implement, say, an ontological formulation of quantum mechanics with relativity, we can't retain relativity of simultaneity. If you implement, say, hidden variables into quantum mechanics, which Louis de Broglie and David Bohm did, this actually results in a preferred foliation of space-time. So there is actually a notion of a universal present in this formulation, and you need it to account for the non-local correlations between spatially separated, space-like separated systems. And connected to this, the claim that matter only exists in three-dimensional space. Well, precisely because of the violation of Bell inequalities, this is what really poses the greatest challenge to the claim that matter can exist in three-dimensional space only. Because, well, essentially, if matter exists only in three-dimensional space and matter propagates only at the speed of light, or that's the maximal speed, then we can't account for these non-local correlations. And in realist formulations of quantum theory, like the de Broglie-Bohm theory and other realist formulations, the configuration space that the wave function of quantum mechanics lives in is what's necessary to account for these non-local correlations. And in those formulations, you need to interpret the configuration space as something to do with an element of reality. It may itself be an element of reality, or it may reflect something about reality in a more indirect way. But one can't naively just say that matter exists in three-dimensional space and that's the end of the story, because then you can't account for these non-local correlations. And the third thing, the Big Bang as creation of matter from nothing. So as someone who studies physics, I'm doing a PhD in theoretical physics, my understanding from a lot of cosmologists is that a lot of them aren't really satisfied with the Big Bang picture as the ultimate explanation of where the universe came from. And they readily acknowledge that. And nowadays, actually since the 1980s, it's been widely accepted that the Big Bang isn't the end of the story, and there are pre-Big Bang models like eternal cosmic inflation, which do allow for fields to exist before our universe and for quantum fluctuations on those fields to give rise to new universes ad infinitum. So the Big Bang itself is not in contradiction. Well, it doesn't necessarily itself imply creation of nothing. You can incorporate the Big Bang model into an eternalist model like eternal cosmic inflation. And eternal cosmic inflation, by the way, makes very specific testable predictions, one of which was confirmed back in, I believe, the 1990s with regard to the spectrum of the cosmic microwave background radiation. So if you're not familiar with all of these aspects of modern physics that I'm talking about, I suggest reading about them, because I think if you study modern physics in depth, you'll find that there aren't really, except for this one particular aspect about matter existing only in three-dimensional space, there aren't really other major contradictions with the materialist philosophy you're talking about.
What would you like to
That's a lot of
answer?
stuff.
Thank you.
18 different things.
Yeah.
It's easier, see, it's a problem. When you have a discussion,
Yeah.
if you throw out 18 different things, it's almost impossible to answer one of them. You know,
You guys are doing that.
You know, I understand, I understand that.
Yeah, there's quite a few physicists are proposing multiverses, parallel universes, all of which is not oxymoronic nonsense. There's only one universe. That's what a universe is.
Based on what?
Okay, let me go through a little story here.
That's tautology.
Little story. At one time, they saw Andromeda. It was a galaxy, eventually proven to be a galaxy. Okay. At one time, these were all called island universes. Every one of the galaxies is called an island universe. Not so.
So what?
Not so.
Wait, guys, you're adults.
What I'm getting at,
Let him speak.
instead of being univarmental, which I was proposing,
Okay.
Give
the
the person a
microcosmic
chance.
and the macrocosmic,
Okay.
what they're doing is like sort of jumping out of it. They're starting to get out of the pre-Copernican view, which is what the Big Bang is, pre-Copernican view of us, me kind of stuff. And so now they're getting out by proposing absurd things like multiverses and parallel verses. Now, remember I showed in our little thing there about a mega vortex as being the next stage in the universe, if it's hierarchical, okay, with no end to it. But we don't propose that those are multiverses or anything of the sort. And we're not proposing that this one was produced out of nothing or a singularity or anything stupid like that.
No, but
First
I'm
of all-
saying that modern physics doesn't make those claims that.
Well, they're backing off, is what I'm saying. It's so absurd. You look at how silly that's going to be. In another 100 years, we're going to say, how could they believe that flat Earth theory?
Well, what does that have to do
Well,
with Big
let
Bang
me get-
cosmology, contemporary Big Bang cosmology?
Let me.
I feel like you're arguing against a straw man, which is this, very, very early
Well, you're-
version of cosmology.
but
It's just
much
not
of what
widely
you-
It's a
accepted.
cosmogony. We don't have a cosmogony.
But much of what you've stated had assumptions, your formulas are based on assumptions, which you don't agree with to begin with. The fact is that the speed of light is not a bar. And let me explain why. What you see right now. If you look at the sun, because light takes 8.3 minutes to get here, you're not seeing the sun where it is. You're seeing it about 20 arc seconds off. Can you, wait, let me answer. I'm getting to it, okay? Please.
Go ahead.
But the gravitational effect of the sun is instantaneous. And yes,
In which
which
theory?
means
In which theory?
that the force carrying the gravitation its motion is extremely much faster than the light. And it's also not parallel with the light.
Who has that view? Where did you get that idea from?
It's just a question of clarification. I'm not
That's all.
trying to
Just wanna know what-
interrupt you to
Well,
be combative.
Who has the view that the gravity travels faster than the light?
I do.
Well,
Okay. Others
Well,
do.
many have complained.
Oh, yeah.
Yeah.
The fact is, the effect of gravity on us sitting right here from the sun is instantaneous.
How
Is
do you
that-
know that? What does it mean?
Yes, because you can measure the direction of the gravity of the effect. The fact is that and when you look at the sun, you're not seeing the sun where it is. You're seeing it 20 arc seconds off. Now, in addition, all these theories about the expanding universe, that the universe is expanding, that all your galaxies are moving away. For instance, Andromeda, you just brought it up. That's blue shifted. It's coming towards us. That cannot be. If all galaxies are moving away from us, and Andromeda is moving towards us, it makes no sense at all.
There is a good explanation for that. I can tell you if you want.
Okay, wait.
But
You're next, sir. Your question. Let me ask you this. The next two people, and then I'll ask. It's 1, 2. Anyone else would like to ask questions after these two? You? Anybody else? Okay, go ahead, sir.
All right, I'm going to avoid physics per se.
Yeah.
I'm more concerned about the assertion of the title, and I think Mike, you mixed, the political
Right.
theory with the physics,
Absolutely.
and I struggle. I mean, I am very interested in all these topics, and I think a lot of us are, and we realize there's a lot of importance here in these topics, and we're not. I think many people are uncomfortable with conventional understanding
Right.
of physics and of the theory.
Right.
And so my question is, you referred, Mike, to dialectical materialism,
Right.
and yet everything that you said, apart from the politics, where I can interpret dialectical to mean something to do with the program of the Russians or whatever, you never mentioned anything that sounded like dialectic. There was no dialectical aspect to what you were talking about in terms of the physics, and I don't think Glenn even brought up dialectic. It was purely about materialism. So I perceive this very one-sided presentation, which is just about materialism, sort of the polar opposite of idealism, which is not a dialectical combination to me. And in particular, Glenn mentioned that he disagreed with Engels because apparently both of you are full-blown determinists.
No.
Or is that just
No,
Glenn?
I'm only determined
Okay, so
left, so.
I had a little hard time differentiating your points of view. Maybe that's just my misunderstanding. But yeah, to me, Engels was clear in some of his fragments that there's a dialectic of determination and chance. And to me, that's essential. Okay, this is my interpretation, because ultimately Marxism is still about still a project of freedom. It's still about liberating us from class society.
Right.
And that means giving everybody the freedoms that only some select people have today. And to me, if science doesn't support that project, if it goes against it, and I see determinism as equivalent to faith. I agree with Ilya Prigogine and others who see a world that is purely deterministic as a world that's equivalent to a world of faith, where basically there's a God or there is a set of universal laws that dictate what will happen, and that we'll all end up in this conversation where I'm asking you this question that may have no point at all, other than the fact that it was determined at some point in the past, whether it began at one point, which I don't believe, or it just ended up here. And I still see, I can't accept that kind of universe. So I think that along with all these other physical concepts that we should question, which you're questioning, and I applaud that, but I think we have to also question the whole notion of determinism. And then I think we may need to have a revolution in our minds as to what determinism means, and maybe it's not exactly the same thing as causation. Maybe there is causation that is grounded, that is negated, that is a negative causation, where the ground is fixed in something that exists, and yet the future is open.
Philosophers have
Yes.
By the way, I agree with you, because I'm not a determinist. Okay.
Okay, I'm glad to hear that.
Okay. And the basis of that discussion is infinity. Because of infinity, you don't have a closed system, which is determinism. You have no way to cool down the universe, because you could take out all the matter you can grab, and you still have an infinite amount of matter in the universe. Therefore, in an infinite universe is the opposite of a finite universe, where everything is governed by entropy and cooling down. In an infinite universe, it's governed by evolution. The universe continuously evolves because the general trend is for matter is based on gravity, and that things move towards each other. Not there's the exact opposite of entropy of those who believe the universe to cool down. That in fact, in an infinite universe, because matter is infinite, because if space is infinite, matter is infinite. And therefore, you can never, as much matter as you try to take out, it's still infinite. Meaning that since entropy does not govern, gravity does. And gravity has the tendency of pulling things together. Therefore, just like in evolution, going from lower to higher stages in evolution, it's the same for the universe. That in the basic function of gravity is to have greater and greater organization, not less organization as they do under the current theories, misusing the second law as entropy.
Well, I wanted to thank the professional scientists in the room for bringing up some of the key things, particularly the Bellian inequality, which it goes to the heart of some of this. But what I wanted to, my concern here is that there actually is an attack on materialism that is taking place in the world today, citing alleged things in modern science as a way of going at it, right? And unfortunately, our panel today didn't get at the heart of that. That's the problem, I mean, and I think that for example, some of us here have both studied modern physics, and we've actually read Materialism and Imperial Criticism, and I've even read Newton's Optics. But at the heart of what I think is happening today is actually flowing out of Popper, for example. The idea that you can only disprove things, you can't actually establish anything as actually being true, and then that opens up the door to relativism, and who's to say that your idea is right versus my idea is right. This is a big philosophical problem that you use to attack dialectical materialism today. And the other aspect is positivism, which is what Lenin actually went after, in Materialism and Imperial Criticism, this idea that we can't really know the reality that exists behind the measurements that we take. All we know is the measurements, and these measurements, if taken, will predict those measurements over here. But who's to say that there's any reality that's out there? Again, it leads to an attack on materialism. Stephen Hawking, for example, in his most recent popular book, actually said in there that there's really no difference between the Copernican theory and the geocentric theory, because each of them can actually be used to correctly predict the relative position of planetary bodies, right? You just add enough epicycles, and it's like a Fourier series, and you can get it as accurate as you want. But really, the planets do go around the sun. They don't travel in epicycles, right? So we actually need to try and look at what is actually happening today in the attack on the misuse of things out of modern physics, the misinterpretation of actual true things that are in modern science, their misinterpretation and their application to attempt to attack dialectical materialism. That was actually the panel that we needed today.
Any response?
I'm not sure I understand the question.
Well, he sort of couldn't understand where they're coming from, and like I had pointed out, I don't know if you were here, 80% of the people in the world are religious. The assumptions that are being used, and this is the problem. If you don't believe that these religious assumptions, like infinity and infinity, okay? A religious assumption happens to be infinity. That makes a big difference. And that's why the consciousness of physics and so on, those items that you see in all of religion affect those thoughts. You have to believe it. And the assumptions are what I got at. That's why everybody should read these 10 assumptions at least. And you can go on Amazon and go pick up on and get more detailed description on that. But if you don't like those assumptions, go do some of your own. And like I said, they have to have opposites, and they have to have no way of proving them. Because why? Because the universe is infinite. We cannot prove, like if you really hope, you really think that we can measure and find out the causes for all effects, good luck. It's not going to happen. So that's an assumption. And I happen to believe it's true. You can call it law if you want, but I call it assumption for a reason, because that's what's the problem with the Big Bang and relativity. Wrong assumptions are being used. Those are religious assumptions. And anybody who has studied physics will be believing those assumptions. Because you don't get through. You don't work as a physicist unless you do. I know people who have quit the physics program because they couldn't stand it. It was disgusting to them. More than 3 dimensions, for crying out loud. What next? 13 string? Waste your life on that kind of stuff? There's a revolution to be done.
Or fields without matter. I mean, this is contradiction, and there is no possibility of having any kind of event taking place without matter. It simply is an impossibility. All forces are push forces, and that's where I came up and tried to explain with the bouncing ball. Wait a minute. The fact is that in order to have curved space, you have to have matter to curve it. a ball in space cannot change, cannot go down. You see these designs, these things on TV where you have, they show in curved space a ball on the net and it comes down. Down is only under gravity. Down is only existing here on Earth. In space, there is no up or no down. In order for a ball in space, or an object in space, or a piece of matter in space, to go on a curve, it has to be being impacted by other matter. That's a basic law of physics. A body in motion cannot change its direction without being affected by other bodies in motion. And then again, if you're postulating expanding this universe, what's on the outside of it? What's on the other side? It's a contradiction in reality. We have to, when we look at all these things, we have to ask, what is the material? To use the word force says nothing. It's not, it doesn't say it hides everything under it. What you need to know when you look at the word, what is the force? What is the material that is carrying that change in motion? What happened to make it? When you jump up and come down, what is the matter that is impacting on you to make you fall down? You can't change direction on your own. You didn't just get tired moving up. There is explanations, but it must be based on physics of reality. That is matter in motion, because that's all that exists, is matter in motion. Time doesn't exist. Time is merely how we measure matter moving relative to other matter. And that's it. A day on Earth is based on the revolving of the Earth. A year revolving around the sun. A day on Mars or Jupiter, or a year on Mars or Jupiter are different. Time is no different. It's just a different way of measuring the motion of that matter around a particular object. Time is, there's this illusion that time is in that clock. The clock, whether it be the ticking clock or a cesium, is a mechanical object. There's no time in there. By the way, the claimed proof of Einstein using the two planes going back, go one going one way and one going the other with the cesium, it actually disproved relativity if you actually believed the clock thing. Because one clock was slowed, one was speeded up. When you go, the theory is you always return as the younger. You never come back as the older. But one of the clocks actually speeded up. So what it really to me showed is that there was a directional flow, just like you have in an airplane going, of the ether. One way you got it carried with you, one way it's against you. And it affects that material object. That cesium does not carry time in any case. It's a mechanical object. Time is merely how we measure the motion of matter relative to other matter, nothing more.
Okay, before I ask the last question, is there anyone who would like to, anyone else who would like to ask a second question? You had
She's
your
had
hand
her
up?
hand up for quite a while.
Okay, well let's change this for a minute, George. Hold on. If she had a hand up before and I didn't see, I'm sorry.
Sure, yeah.
You're next,
So
George, and then you. And then
This isn't meant to be a long question, but I want to ask a question and maybe respond to what you say. So just to be clear, you're claiming that when the ball falls back down, it's because it's being pushed
Right.
by
It's a
matter?
push force.
So-
All forces are push forces.
So what is that matter? What is the name for that matter?
Well, to me, it seems obvious to me the answer. What you're having is, it's not like the table where you go bang, like this. You're slowing until you get to equilibrium, and then you're coming back and speeding up. That means, by almost definition, you're not hitting one object. You're hitting lots of different things that slows your progress up and then it hits the equilibrium, and that's those things that are hitting you as you move you down and speed you up as you're going down, because the accumulation of the hits from, and I'll call it the ether. Okay.
I mean, basically what I'm saying is that it's perfectly consistent. In fact, I can't think of a materialism that doesn't have, as part of its materialism, as part of its theory, an understanding that there are both, let's say, physical, material, tangible entities, and then there are ways in which they interact, let's say.
Right.
So now we can name some, we can list like gravity or magnetism or whatever. But like, it's okay to be a materialist and for your, as we say in philosophy, ontology to include more than just actual physical objects, but also like the relationships that exist between them. And in fact, like if you were to really analyze your account of, I don't know if you want to call it gravity or if you want to give it another name, like take the story further, you still have to give an account as to why the ball stops coming back up and why that equilibrium, as you're calling it, changes, right? Like you still have to talk about like forces, let's say, or relationships, right? Because on the one hand, you're trying to say like, oh, well, there are these push forces, but on the other hand, you're trying to say like, it's just hitting other objects. And so that's kind of two different accounts,
well,
and you have to...
Under, there was a 1742, and this, I'm not giving it as the exact answer, but it gives you a kind of an idea. Lesage theorized that his gravitons were screened. In other words, you're sitting on the Earth here. The mass of the Earth is screening the gravitons from that direction. So you're getting hit more from this direction where you're not being screened. And so therefore there's this imbalance that in fact gravity is that imbalance because his formulas, which obviously were of that period, so they're not exact, did meet the inverse square law exactly, and they, in a general sense, give a sort of an answer. I can't give you more of a clear answer. I'm not trying to propose exactly. All I'm saying is, when you're dealing with matter, all forces are push forces. There's no such thing as a pull force. If I put a rope around you and pull on you, it's really a push force because of the rope that goes around you is pushing you. And every action that is where matter meets other matter, all these interactions are push forces.
So magnetic forces as well?
Yes. See, a force is, we use that word force because when we do not know the actual mechanical cause. We know the result. When you do F equals ma, you know the result. But you don't always know what that force is. You know, you give it the name energy, you give it whatever it is. But that's just a name for something where you're admitting you don't exactly know what the material action is happening. That what is it? What matter that is interacting with other matter? How you see the effect, but it's still yet to determine what it is, what the interactions are that are causing that.
Next question, and then the last question will be
I
okay.
have one question and one comment. I'll try and make them both brief. The Big Bang Theory, I remember reading about that, I don't know, 30 years ago. It made a certain amount of sense to me until I read an article, I think it was in Time magazine, that made it clear that there was a creationist thing behind that. Mm-hmm. So I recognize that, however, still needs to me to be an explanation. I'm sure there is one that I haven't heard or don't understand about the Doppler effect of the redshift and the galaxies. You can't get around it by just saying, well, one galaxy has a blue shift and it's moving closer to us if most of the rest of them are moving away. I just don't understand that. I've read couple of things which didn't make sense. Just to comment very briefly, because one of the things that I give credit to Mike for is he made me reread at least portions of materialism and material criticism. I do not think that Lenin attacked relativity as such. He attacked the idealist view of the physicists who were seeing different kinds of matter and different kinds of matter in motion and put it in an idealist context. But I do not think he attacked relativity as such, and I don't even know if it was around at that point.
He was attacking Ernst Mach.
Yeah.
The bucket, the rotating bucket.
Well done.
In reference to the redshift, where they postulate all these galaxies further and further and further away are moving faster and faster and faster away from us. And in fact, you go far enough and try the speed. Some of the galaxies have redshifts 4 times the speed of light. It's what you're. But if you look at it in a different way, it makes complete sense that they're not. That is, if light is a wave, it spreads out according to the inverse square law. It spreads out to the inverse square. The further away from the source, the more attenuated the wave is. Therefore, if a galaxy is X distance away, the further away over it, they'll be more redshifted. It is what it is. Doesn't mean that it's moving away.
How does attenuation change the frequency?
The radiated power is constant because the sphere's area increases.
Yeah, there's a difference between
Frequency and attenuation.
Yeah. Constant, that's why.
Yeah. That's just.
Or you wouldn't be able to.
There's a difference between frequency and amplitude.
Mhm.
The inverse square law applies to amplitude. It doesn't apply to the frequency. It's just confused.
Well, change the frequency means you're losing energy, right, or motion, whatever. And that's what happens over distance.
Yes. You're not going to maintain the frequency over distance. You're trying to say that a wave in water, for instance, is going to cross the Atlantic Ocean and maintain its same frequency?
No.
It's not. That's
It
ridiculous.
doesn't have a frequency. What are we
Waves. They both lengthen out and they lose.
Guy, you're gonna have your last question. Why are you interrupting?
That's how science is done.
No. This is. We gotta respect each other. Stop it. Okay? Come on. You want your question now? Go ahead.
All right. I'm actually a professional cosmologist. Well, I don't know if I'm a professional cosmologist.
What?
Cosmologist. My PhD is in relativity and cosmology. The Big Bang Theory, so I think most people have the right idea. No one believes on a singular event, so there's some sort of smoothing. And furthermore, even, any theory that actually solves the technical problem of producing a universe from some quantum state, everything is going to be finite or we'll chuck the theory. That's what gravity is and, quantizable, blah, blah, blah.
Speak up, so
Yeah, louder.
Sorry, so what I'm saying is when we have a theory, nothing will be infinite, or it's not acceptable. Gravity is not, you might have heard gravity is not quantizable. Yes, that's precisely because when we try to quantize it, we get infinities, technical stuff, but, and that's not acceptable, okay? So, there are people in Canada who claim, we can get a finite volume, finite energy universe, blah, blah, again, no infinities will be accepted, okay? So it's just not it's not a problem of physics, all right? So you just put that aside, whether you believe in Cantor or not, it's irrelevant to physics, okay? Now, but anyway, I think he and you have both covered the physics well enough over here, so I'm not. But I don't know, to sort of I could probably apply Oscar Wilde's sort of, in the face of injustice, attack is the best form of politeness or something. Well, so I'm going to be slightly impolite and say, this is actually retrograde.
Yeah.
Okay. This is, in fact, your narrative is even less coherent, okay, than intelligent design narratives, which are actually, they go really, they do have cash, they probably have more cash than you, and definitely less coherent than the global warming sort of retrograde.
Deniers, yeah.
Yeah, I mean, okay, so this is actually retrograde. I'm just going to, everyone knows this, you're being polite, okay? I'm the scientist, sorry, I'm not sophisticated, I'm going to be impolite, right? This is retrograde, right wing, okay? I mean, this is nothing to do with dialectical materialism,
No.
right? Nothing at all.
Against it. I
Right?
agree. I agree, this is not gonna.
Okay. 4 o'clock. Our time is up. I'd like to thank you all for coming, for participating.